It is often said that thickness is strength, that more mass means more power, that heavier means tougher. But real strength is not in thickness, it's in bone, not in flawlessness, but in the ability to bend, absorb and endure. Welcome traveler, I am Aytaç Ertekin and this is SITU, Silence in the Universe. Toolbox is where we study the materials that make civilizations possible. In this episode, we unfold graphene, a two-dimensional material made entirely of carbon, one atom thick. Its atoms form a hexagonal lattice where each carbon shares 3 covalent bonds, leaving one electron free to move across the sheet. A cosmic honeycomb. Let's open it together. The carbon that refused to stack. Graphene is not rare. It hides in pencil lead, in soot, in the ash of burnt wood. It's mundane. It's carbon. No exotic elements, no alien physics. Just a single layer of atoms, arranged in hexagons. It is a specter, almost weightless, nearly invisible. Yet it haunts the limitations of every material that came before it. So thin, it's almost not there. And yet, with a tensile strength around 130 gigapascals, it is stronger than steel by weight. It conducts electricity more efficiently than copper. It bends without breaking. It absorbs light, yet remains nearly transparent. How? Each carbon atom forms 3 covalent bonds in a planar lattice. No atom dominates. Each contributes. The strength emerges from connection. When imperfection does not mean collapse. Steel fails because its atoms align in rigid grids. Stress travels in straight lines. Cracks propagate cleanly. Graphene behaves differently. When a defect appears, a missing atom, a distortion, a grain boundary, stress does not always travel in a single catastrophic direction. The lattice can redistribute load across neighboring bonds. It does not eliminate weakness. It disperses it. Graphene does not depend on perfection to survive. Its resilience is structural. This is how material science becomes material philosophy. A one-atom thick revolution. Graphene carries electricity with extraordinary efficiency. Its electrons move as if they are massless, following relativistic equations normally reserved for high-energy physics. Inside this sheet, they behave like particles described by the Drake equation. It filters salt from seawater. It charges batteries in minutes. It senses single molecules. Its strengths composites without adding weight, lightweight conductors, radiation-resistant composites, ultra-thin solar sails, the quiet infrastructure of deep space. One sheet, one layer, one structure. Yet, in its simplicity lies the blueprint of enduring systems, resilient, adaptive, and interconnected. It works because every atom is connected. No one dominates, yet all contribute. Carbon does not compete, it cooperates. Carbon does not dominate. It connects in DNA, in proteins, in nanotubes, in graphene, in life itself. Structures of accumulation built on concentration fracture under stress. Carbon thrives in distribution. Graphene is not powerful because it is thick. It is powerful because its structure shares load across the whole. Emergence. One atom alone is silent. A million atoms bonded in coherence become something no atom alone can be. Value emerges from connection. Function emerges from structure. Graphene is a lattice where no node is special, yet every node is necessary. The future built from sheets. The future will not be built from heavy blocks. It will be woven from layers. Smart surfaces, adaptive skins, energy membranes, neural interfaces, artificial retinas. Graphene membranes already filter water molecule by molecule in laboratory demonstrations and early pilots. Laboratories already tested in flexible electronics and spacecraft composites. A civilization that travels far from its star will not rely on mass. It will rely on structure. Strength is not mass. It is structure. Survival is not perfection. It is redistribution of stress, of energy, of responsibility. Carbon has always known this. And graphene, the thinnest form of matter we can isolate, remind us to endure is to bond.